Webb Space Telescope pointed its mirror in the deepest, oldest parts of the sky, it kept finding the same strange thing. Small, impossibly bright, blazing red. And according to every rulebook astronomers had for what can and can't exist in the early universe, it shouldn't have been there at all. They weren't stars. They weren't ordinary galaxies. They weren't quite black holes either, not the kind anyone recognized. For nearly 3 years, nobody could agree on what they actually were. Scientists gave them a deliberately understated nickname, almost as if downplaying how strange they really were: little red dots. One especially extreme example got its own name. Astronomers started calling it simply the cliff, because its light profile did something that, by the physics anyone understood at the time, it had no right to do. And here's the part that makes the story worth telling right now, in 2026, instead of 3 years ago when this all started. Astronomers think they've finally figured out what these things are. Astronomers think they've finally figured out what these things are. The answer, when it came, was stranger than the mystery itself. This is the story of an object that showed up in almost every deep JWST image ever taken, refused to make sense for 3 straight years, and turned out to be something the universe had never shown us before. I'm Jameson Evans, and today we're going all the way into one of the strangest open questions in modern astrophysics, solved more or less in just the last few months. We'll understand exactly what these things are, and why the answer says something bigger about how the very first black holes in the universe were born. To understand why this discovery is such a big deal, you need to understand what James Webb was actually built to do. The James Webb Space Telescope launched in December 2021, designed as the successor to Hubble's bigger mirror, tuned to infrared light instead of primarily visible light, which matters enormously for one specific reason. Light from the most distant objects in the universe gets stretched by the expansion of space itself, shifting it toward the red end of the spectrum and beyond into infrared. The farther away something is, the redder and the more infrared its light becomes by the time it reaches us. Hubble could see a lot. Webb was built specifically to see past where Hubble's vision ran out, into the deepest, earliest chapters of cosmic history. Nobody expected Webb's very first deep images to immediately break something. But that's essentially what happened. Almost as soon as the telescope's first data started coming in during 2022, astronomers going through the images kept spotting the same odd little smudges. Small, extremely red, extremely compact points of light showing up in field after field, at distances corresponding to a time when the universe was only a few 100 million years old. They were common, not rare exotic one-offs, genuinely common, popping up practically everywhere Webb looked that far back in time. That abundance was the first clue that something big was going on. A weird one-off object is a curiosity. An entire population of weird objects showing up over and over across independent surveys is a sign that you've found a genuine feature of how the early universe works, one nobody had predicted. Here's where the story gets its first real twist, and it starts with a different but closely related discovery that came just before the little red dots got their name. In February 2023, a team analyzing Webb's very first release of imaging data published a result in the journal Nature describing 6 candidate galaxies from just 500 to 700 million years after the Big Bang, when the universe was about 3% of its current age. These should have been small, young, barely formed infant galaxies. Instead, the data suggested some of them already contained roughly as many stars as the Milky Way has today, with one candidate estimated at up to 100 billion solar masses in stars alone. Joel Leha, an astronomer at Penn State who worked on modeling the light from these objects, put it plainly. These objects were, in his words, way more massive than anyone expected. Astrophysicist Erica Nelson, who helped identify them, gave the group an informal nickname that stuck immediately: universe breakers, and described the team's initial reaction to the data in 2 words: "This is bananas." The problem wasn't just that the galaxies were big. It's that standard cosmological models, the equations that describe how matter clumped together after the Big Bang to eventually form galaxies, didn't have enough time and arguably not enough raw material to build something that massive that fast. If confirmed exactly as measured, these objects were in tension with the vast majority of existing models of how the universe assembles itself. But here's the thing about science working the way it's supposed to: those first measurements were not the final word. Follow-up spectroscopy, a more precise way of measuring an object's exact distance and composition by splitting its light into a full spectrum rather than just a color estimate, found that at least one of the original 6 universe breakers wasn't nearly as distant as first thought, and that its extra brightness was actually coming from a feeding black hole, not from an unexpectedly large population of stars. One mystery quietly resolved. 5 more still open. That single correction turned out to be an important clue for the bigger mystery, because it pointed to the same suspect that kept showing up everywhere else in this story. Black holes hiding inside light that looked, at first glance, like it should belong to stars. The little red dots take center stage. By 2023 and into 2024, as the universe breakers question kept getting refined galaxy by galaxy, a separate, much larger population of objects was drawing its own dedicated attention, the little red dots. Unlike the 6 rare universe breaker candidates, there were hundreds of these things, showing up across nearly every deep JWST survey of the early universe, at times corresponding to roughly the first 1 or 2 billion years of cosmic history. They had a strange set of properties that didn't fit neatly into any existing category. Their spectra showed broad emission lines from hydrogen and helium, the signature of gas moving at very high speeds, which usually indicates material swirling and falling into a supermassive black hole. But if they really were black holes feeding at the rate their brightness implied, they should have been blasting out X-rays and radio waves the way essentially every other known supermassive black hole does. They weren't. Whatever these things were, they were extremely luminous and extremely quiet at the same time, a combination that, before this, basically didn't exist in the astronomical rulebook. And then, just to make things stranger, the little red dots did something else unexpected. They largely vanished. Show up in force during the first roughly 2 billion years of the universe's history, and then, moving forward in cosmic time, the population thins out and effectively disappears. Whatever process was creating them appeared to be a phase, something that happens early and then stops. For roughly 3 years, this was one of the most actively debated open questions in observational astronomy. Were these small, ultra-dense pockets of extreme star formation some entirely new category of compact galaxy? Black holes wrapped in something that was muffling their usual X-ray and radio signals? Nobody could rule any of it out cleanly, and the debate showed up in dozens of competing papers. Here's why this story belongs in a video published in 2026 instead of any point in the 3 years before it. The mystery has, in the last several months, largely broken open, and the explanation is one of the strangest ideas modern astrophysics has produced in years. Multiple independent research teams, publishing around the same time in late 2025 and into early 2026, converged on essentially the same answer using Webb's highest quality spectra of these objects. The broad emission lines that made little red dots look so extreme, it turns out, aren't primarily caused by gas swirling at extreme speeds around a black hole in the way scientists originally assumed. Instead, the light appears to be passing through and being scattered by an extremely dense cocoon of ionized gas, a phenomenon called electron scattering, which broadens the light's spectral signature in a way that mimics, but isn't quite the same as, the classic signature of a feeding black hole. That distinction matters enormously because when researchers reworked the math using this new interpretation, the estimated masses of the black holes at the center of these objects dropped dramatically, by roughly 2 orders of magnitude, meaning around 100 times smaller than earlier estimates. Instead of being impossibly overmassive monsters that shouldn't have had time to form, many little red dots turned out to house black holes in the range of 100,000 to 10 million solar masses. Still young, still growing unusually fast for how early in cosmic history they appear, but no longer quite as flatly impossible as the earliest estimates suggested. Rohan Naidu, an astrophysicist at MIT who worked on one of the key 2025 studies, has started calling these objects black hole stars, rather than little red dots because of how they actually behave physically. In his own description, they effectively radiate like enormous stars, even though the energy source powering that radiation is a growing black hole at the center, not nuclear fusion. That explains why little red dots look so quiet in X-rays and radio for so long. The same dense cocoon of gas that scatters and reshapes their visible light also appears to absorb much of the X-ray emission that would normally give away a feeding black hole immediately. They weren't quiet because they weren't black holes. They were quiet because they were wrapped in something thick enough to muffle the evidence. And then, in a separate line of evidence, astronomers found something that helped confirm the black hole interpretation directly. Researchers compared the location of one particular little red dot to years of archival data from NASA's Chandra X-ray Observatory and found a faint but genuine X-ray source sitting in exactly the same spot. A signature consistent with a black hole after all, just a much fainter one than expected. Princeton astronomer Andy Golding, describing the discovery, noted that the X-ray signal had been sitting in Chandra's archive for over a decade before anyone realized what it was sitting on top of. Put all of that together, and here's where the mystery stands as of 2026. Little red dots appear to be a genuine, previously unknown phase in the life of the universe's very first supermassive black holes. A brief, extremely early window, roughly the first 2 billion years of cosmic history, when young black holes grow inside dense cocoons of gas bright enough to appear almost everywhere Webb looks, before that phase ends and the objects either grow past it or fade from view in the way we currently observe them. What's still not settled is the question underneath all of this. How do you get a black hole of 100,000 to 10 million solar masses within the first few 100 million years of the universe's existence in the first place? Ordinary black hole formation, growing gradually from stellar remnants merging over billions of years, doesn't obviously have enough time. Competing ideas: direct collapse of massive gas clouds straight into black holes without an intermediate star phase, black holes feeding at extreme super-Eddington rates that outpace normal growth limits, or rapid runaway mergers between smaller black holes early in cosmic history, are all still being actively tested against the data little red dots are providing. The little red dots didn't just answer a question about strange red smudges in Webb images. They opened up a much bigger one about how the universe's first monsters got so big so fast. There's something worth sitting with in this story, beyond the specific physics of gas cocoons and electron scattering. For 3 years, one of the most common types of object in the deep early universe was hiding in plain sight, disguised by its own bright light as something it wasn't. Every deep field Webb captured almost certainly had them scattered across it from the very beginning. Nobody had a name for them, let alone an explanation, until enough independent teams looked at the same puzzle from enough different angles that the disguise finally slipped. That's not really a story about a telescope finding something impossible. It's a story about how much of what looks inexplicable is actually just poorly understood, and how the universe's oldest, strangest-looking objects sometimes turn out to be ordinary physics, wearing a costume nobody had seen before. The black holes at the center of little red dots aren't breaking the rules of astrophysics. They're revealing a phase of those rules nobody had directly observed until a telescope finally got close enough and patient enough to look. The mystery isn't fully closed. Nobody yet knows exactly how the universe managed to build black holes this large this quickly, and every new little red dot Webb finds is another data point in that unfinished argument. But for the first time since these objects showed up in Webb's very first images, astronomers finally know approximately what they're looking at, and that, on its own, is one of the more remarkable turnarounds in recent astronomical history. If you want to understand what happens as astronomers keep testing this explanation, and whether it finally solves the deeper mystery of how the universe's first supermassive black holes were born, subscribe and turn on notifications. Drop a comment with which part of this surprised you most, and share this with someone who'd want to know that some of the strangest objects in the universe were hiding behind their own light the entire time.